In today's episode, the architecture decision that reveals everything. You're tuning into Human Architecture Assessment, a structural evaluation of how humans and the systems around us exist and their implications. I'm your host, JAPEXJESS. For years, the iOS community has debated which architecture pattern is the right one. MVC, MVP, Viper, TCA, MVVM. The debate has always been framed as a trade-off: simplicity versus power, speed versus correctness, flexibility versus guardrails. That framing is no longer accurate. AI has changed the underlying economics of the decision, and when the economics change, the right answer changes with them. The way the industry has been evaluating architecture patterns is missing the most important variable in the room. The conventional comparison of MVVM versus TCA, the composable architecture, assumes a thin view model, one that directly calls dependencies, does a little bit too much, and in general becomes a mess. That's not MVVM. That's an incomplete implementation of MVVM being compared against a mature, fully specified framework. And the conclusion that TCA wins is baked into the framing before the argument even begins. A properly structured MVVM architecture has 6 distinct components. The view renders UI, the view model handles model data for the view, the interactor owns business logic and state, the repository becomes our data source abstraction, deciding where data comes from, network to call, caching, local storage. The service layer localizes our network calls by topic, each service owning a specific domain of API communication. And the network layer handles our raw HTTP. This is MVVM and clean architecture, and it changes every comparison that follows. When you map TCA versus MVVM and clean architecture, they're structurally equivalent, the same architecture expressed in different syntax. TCA's reducer is the interactor, the action item is the interactor's public interface, the dependency environment maps to the interactor and the repository combined, and TCA's view store is the view model. Where the mapping gets interesting is the data layer. TCA's effects absorb what MVVM and cleans separates into 2 distinct layers: the repository, which acts as the data source, and the services layer, which localizes network calls by topic. TCA collapses that separation into the effect implementation itself, whereas MVVM and clean keeps them distinct. That separation is one of the cleaner aspects of the architecture. Most of the TCA versus MVVM debate is a comparison against thin MVVM, not this. That means the debate has never actually been about which architecture is more powerful. It's been about which implementation has better tooling, better enforcement, and better ergonomics. That's a very different question with a different answer. In production, 2 a.m. and something's broken. You're starting from a crash report. In MVVM and clean architecture, the call chain is structurally linear. View to interactor, to repository, to service, to network. With swift concurrency, async await suspends and resumes across execution contexts. The call stack at the point of a crash won't be perfectly clean, but the logic chain remains readable top to bottom. Direct method calls between layers mean you can trace the execution path through the code structurally, even across asynchronous boundaries. Immediate context, minimal reconstruction. In TCA, the effects are architecturally detached from their dispatch origin by design. The debugging path looks like this. You start with the action log and reconstruct outward. Which action was fired? Based on the action, what was the state change produced in the reducer? Which effect kicked off the network call? The connection between the original UI event and the failure is not traceable directly, and that indirection isn't a concurrency artifact, it's structural. You're reconstructing what happened rather than reading what happened. Now, with a coding assistant, the gap closes partially for plan development, and for greenfield feature work, with the context loaded, the difference is manageable. But production incidents don't come with context loaded. The entry point in TCA is structurally further from the origin, and that gap doesn't disappear just because you have an AI. At 2 a.m. in production, that difference is not academic. TCA's most defensible advantage has always been framework-enforced consistency. Structural guardrails that prevent architectural violations without relying on team discipline. Swift macros addresses this directly. They generate boilerplates for interactors, repositories, and view models consistently. They enforce interface contracts between layers at compile time, and they standardize patterns across the team without requiring a third-party framework to do it. Macros enforce contracts at boundaries. Everyone enters through the door. TCA's single writer state invariant goes one step further. There's only one door. That residual gap is real. That gap closes with one addition to the stack. The remaining gap, behavioral compliance inside a layer, not just its interface contract, is closed by integrating an AI for code review into the CI pipeline with the merge block on failure. Think of it as two enforcement layers working in combination. Macros handle structural contracts at compile time. Binary, either it compiles or it doesn't. The AI code review handles behavioral pattern compliance inside the layers, catching lateral interactor calls, notification side channels, business logic leaking into the wrong layer, responsibility accumulating over time. The merge block makes that second layer deterministic. You cannot merge until the AI passes the PR. Two things make this more powerful than TCA's enforcement model, not just equivalent. First, TCA can enforce structural invariance, but cannot catch a semantically wrong, syntactically valid reducer. The AI layer can. Second, TCA's enforcement ceiling is fixed by what the framework authors encoded. The ceiling rises with every model generation without changing your architecture. One prerequisite for this AI CI pipeline to work, a team needs the operational maturity to own CI tooling and maintain architectural context prompts. So that investment needs to proceed in order to benefit. For senior heavy teams, MVVM and clean architecture holds naturally. Conventions are maintained, flexibility is maximized, and debuggability is highest. For junior and mid-level heavy teams, TCA is a well-designed set of guardrails for teams that need structural protection while building architectural maturity. The framework's built-in constraint provide real bug protection and prevent architectural violations that would otherwise compound silently over time. And for a scaling senior team, MVVM and clean architecture, with the addition of a Swift macros layer and AI gated CI, is the right direction. Macros and the AI gate codify conventions in a way that survives team composition changes over time. I want to be direct here. I've used TCA at multiple companies, and the guardrails were real. There was a meaningful learning curve, so engineers coming from MVVM and Clean took a bit of time to contribute confidently in TCA, though the point-free tutorial videos did a pretty good job of closing that gap. And with code bases that already followed a TCA-like structure, the migration was largely lateral. During the post-effects era of TCA, debugging through the async effect chains produced some friction in production. And that's where the structural distance from the origin becomes tangible rather than theoretical. But overall, the experience was more positive than painful. The risk that doesn't get discussed enough is structural coupling. TCA is MIT licensed and fully open source. The source is available and forkable. The coupling cost is different in nature. It's about how deeply TCA stores scopes through your view hierarchy and what that costs when the framework evolves. Over a 3-year period, TCA shipped 95 releases with at least 5 paradigm-shifting migrations. One developer documented a whole work week, 5 days, to migrate a single 33-feature app across one of those transitions. Rod Schmidt, April 2024. Bright HR's engineering team captured the structural reality of this directly. They attempted to upgrade one parent view and discovered it was impossible to upgrade that view without upgrading everything it scoped to. The engineer described it as pulling up floorboards in one room and realizing they connect to the hallway, then the living room, then suddenly every room in the house, a spiderweb you can't keep track of. The upgrade had to be dropped repeatedly in favor of feature work. Bright HR engineering blog. That's not a licensing problem. That's an architectural coupling problem. And it's one that compounds as the codebase grows. MVVM and clean architecture doesn't have this problem by design. Layers are independent, migrations are incremental, and the coupling graph is yours to control. TCA is widely praised for exhaustive state transition auditability. This is its most cited remaining advantage. Here's what that looks like in practice, and where it stops. MVVM and clean architecture can implement an opt-in state manager that captures every state transition with full fidelity. Previous state, new state, a typed property level diff showing exactly what changed, timestamp, thread, and the complete runtime call stack, all at the moment of mutation. The last item is the critical one. In TCA, a state transition record tells you what changed and which action caused it. What it cannot tell you is why the action was dispatched from the perspective of the runtime. The actual call chain that preceded the dispatch is outside the framework's visibility. The action enum is the entry point into TCA's world. Everything before it is invisible. In MVVM and clean, state mutations happen through direct method calls. The runtime call stack is complete and meaningful at the point of mutation. The state manager captures it using a foundation primitive available since iOS 4. And the transition record doesn't just tell you what changed, it tells you exactly what code path caused it, traceable to a line number. TCA state auditability is a flight recorder for the action layer. It starts recording after the plane is already in the air. The MVVM and clean state manager starts at the runway. The full journey is in the log. This is not a replication of TCA's auditability. It's a structural improvement, opt-in, additive, and owned entirely by your team. But AI inverts the economics of the entire decision. The traditional justification for opinionated third-party frameworks was always an implementation time argument. Less boilerplate, less infrastructure, faster to production. TCA's advantage was real when the alternative meant weeks even months of senior engineering time to scaffold correctly. AI collapses implementation time across the complexity spectrum. The cost differential between letting TCA handle it and owning a full MVVM, clean, macros, CI, state manager stack shrinks towards zero. And when cost is approximately equal, you always choose the path with more ownership, more debuggability, and the higher ceiling. This runs deeper than the TCA comparison. Frameworks like TCA exist because complexity had a cost. AI reduces that cost. The justification for ceding ownership weakens across the board, not just for TCA, but for the entire category of opinionated framework as shortcut. The instinct in the industry right now is to use AI to go faster on the simple path. The more powerful move is to use AI to make the complex path accessible, and then choose complexity deliberately when it earns its keep. Own the complexity. AI just made that affordable. Okay, so when it comes to architecture patterns, where are they now? Well, MVC, it's simple and fast, but doesn't scale. Useful for prototyping, not production. Using MVP is a stepping stone, but not a destination. And the thin MVVM is the most commonly misrepresented baseline in the comparison literature. It's not a fair representation of the pattern. Now, Viper, that predates the macros and AI error. Most of its boilerplate code is no longer justified. It solved real problems in 2015, but those solutions have been superseded. TCA is genuinely well designed for what it does. High testability, meaningful scalability, real enforcement value. Its ceiling is fixed by the framework authors, its coupling costs compounds at scale, and its debugging overhead grows with the code base. For teams that need framework enforced structural protection, it delivers that reliably. Now, MVVM and clean architecture with Swift macros, AI-gated CI, and an opt-in state manager is the answer when you own the full stack. And AI is in the loop. Testability is very high. Boilerplate cost is dramatically reduced by macro generation and AI assistance. And scalability has no practical ceiling. The complexity is real, but the guardrails are enforced and the ceilings rise with every model generation. Fully owned, framework agnostic, built for the AI era. TCA was the right answer when complexity had a cost, and the only enforcement tools were compilers and human review. AI has changed both of those conditions simultaneously. The debate was never about which architecture is more powerful. They're structurally equivalent. The debate was about which one is more practical to own, enforce, and debug across the full life cycle of a real product with a real team. When you factor in structural ownership, production debuggability, macro enforcement, AI-gated CI, and a state manager that structurally exceeds TCA's auditability, MVVM and clean architecture is the answer for any team with the maturity to own it. For teams where framework enforced structural protection is still the right call, TCA delivers that reliably. The question worth asking is whether that condition applies now, and whether it will still apply in 2 years. The sophisticated choice is not the one that abstracts away complexity. It's the one that makes complexity affordable. AI just changed what's affordable. That's it for this episode. And remember, people make excuses for what they want. What do your excuses reveal?